Okay, today's lesson is 4.4a, any angle trig. In this section you will evaluate trig functions of any angle. Use reference angles to evaluate trig functions. Okay? Alright. Just to refresh your memory, the trig functions have signs in different quadrants. All trig functions are positive in quadrant 1. Sine and cosecant is positive in quadrant 2. All the other ones are negative. And tangent and cotangent are positive in quadrant 3. All the other ones are negative. And cosine and secant are positive in quadrant 4, and all the other ones are negative. State the quadrant in which theta lies. If sine is positive and tangent is negative, which quadrant are we talking about? Well, we know that sine is positive in quadrants 1 because everything's positive in quadrant 1, and it's also positive in quadrant 2. Tangent is negative in in 2 and 4 because everything's positive in quadrant 1 and tangent is positive in quadrant 3. So it is negative in quadrants 2 and 4. So where is it? Where is the angle negative? Sine is negative in quadrant, where is the sine of angle theta positive and tangent of angle theta negative? That would be in this quadrant right here, in quadrant 2. Okay. State the quadrant in which theta lies if cosine of theta is positive and sine of theta is negative. Cosine is positive in quadrants 1 and 4, and sine is negative in 3 and 4. So the angle must be in quadrant 4. State the quadrant in which theta lies. Tangent of theta is positive and secant of theta is negative. So tangent is positive in quadrants 1 and 3, and secant, which is the reciprocal of cosine, is negative in quadrants 2 and 3. So we're talking about quadrant 3. Okay. So, first question for today is state the quadrant in which theta lies. Sine of theta is positive and secant of theta is negative. Alright. Reference angles. A reference angle, theta prime, is the acute angle formed by the terminal side and the x-axis. Okay, so far in this class we've only talked about angles in quadrant 1, or acute angles, angles less than 90. Okay, all the trig functions we've been talking about were in quadrant 1. What if the angle is, the terminal side is not in quadrant 1, it's more than 90? So now we're talking about trig functions of any angle. Well, we will need a reference angle. We will have to make believe that our angle is in quadrant 1. Okay, so we're going to have to make it less than 90. Anything that's less than 90. Okay, so let's see. It would be this angle here would be our reference angle. We're trying to get it back to the x-axis. Okay, the reference angle is the acute angle less than 90 formed by the terminal side, which is this one, and the x-axis. So it's the angle between the terminal side and the x-axis. Okay, how do you draw a reference angle? You always draw the reference angle to the x-axis. So we have this point here, so we're going to draw it to the x-axis. Okay. You're going to have trouble if you try to draw it to the y-axis. Don't draw it over here. It's not the angle in between here. It's always to the x-axis. What about this one? How do I draw this one? I always draw it from the terminal side to the x-axis. So it's the angle in here. That's my reference angle. Alright. So, here's a little Pac-Man with an eye. No. Well, okay, this angle right here, so we always want the angle less than 90. So we always go from the terminal side back to the x-axis. Okay? So if you're doing it right, well, I forgot this one. If it's already in quadrant 1, then the reference angle is that same angle, so we don't have to do anything with that one. Okay. All right. If you're doing it right, your reference angles should always look like this, like a bow tie. Okay, don't draw it over here. It always goes back to the x-axis, like a bow tie. All right. So the reference angle is measured from the x-axis. Okay, so right there, there's your reference angle. If it's quadrant 1, the reference angle is, if it's in quadrant 1, the reference angle is the angle. In quadrant 2, it's going to be this angle over here. So it's going to be 180 minus your angle gives you your reference angle. Okay, this is 180 minus this angle here will give you the reference angle here. Right? If we're in quadrant 3, we're going to have to take that angle that's more than 180 and subtract off 180 to get the angle in here. Okay, always back up to the x-axis. And if we have an angle that's greater than 270 in the third quadrant, then we have to subtract it from 360 to get the angle going back up to the x-axis. Okay, so here is your key, depending on which quadrant you're in. If the angle's between 0 and 90, that's fine. If the angle's between 90 and 180, then subtract it from 180. If your angle's between 270 and 180, then subtract 180 from your angle will give you your reference angle. If it's more than 270 and less than 360, It's in quadrant 4, so you subtract off 360 to get your reference angle. Okay, for our angle 30 degrees, what is the reference angle? Well, the reference angle in quadrant 1 is just the same angle. Okay, it's fine. We're only trying to get an angle, an acute angle, less than 90. So what about this angle here, 132 degrees? What is the reference angle? Reference angle is back to the x-axis, so it would be in here, 48 degrees. 180 minus 130 is 48. What about this angle here? Since this angle is more than 1 pi, now we're in radians, right? It's 8 pi over 7. So this part right here, we would have to get the reference angle is pi over 7, because we have to take pi, subtract off 8 pi. Ooh, I wrote that backwards. It should be 8 pi over 7 minus pi, which will give you 1 pi, because this is 7 pi over 7. 8 pi over 7 minus 7 pi over 7, which is 1 pi over 7. What about an angle that's in quadrant 4? In radians, it would be 15 pi over 8. So I will need to subtract 2 pi by 15 pi over 8. So 15 pi over 8 is 16 pi over 8 minus 15 pi over 8 gives me 1 pi over 8. Okay, for this example, we have an angle that's negative 140 degrees. What is the reference angle? We know the reference angle's in here, but my negative 140 is really positive 220, right? 220 plus 140 is 360, so it's a positive 220. How do we find the reference angle for an angle that's in quadrant 3 that's 220? We would subtract off 180, so 220 minus 180 would give you 40. So that's my reference angle. Or you can take this half angle here, 180 minus the 140, that will still give you 40. Or you can take this positive 220 and subtract off 180, that will still give you 40 degrees. Find the reference angle for 74 degrees. Since it's less than 90, then the reference angle is 74 degrees. Find the reference angle for 300 degrees. 300 degrees is in quadrant 3, so the rule is to subtract theta from 360, so the reference angle is 60 degrees. 3 pi over 4. 3 pi over 4 is almost 1 pi. It's between 1 pi and half a pi, so we're in quadrant 2. So we subtract 1 pi from, we subtract 3 pi over 4 from 1 pi. And finding a common denominator, this is going to be 4 pi over 4 minus 3 pi over 4, which is 1 pi over 4. Three 2.3. Since that doesn't have a degree symbol, this is in radians. This one's a little tricky. See if you can think about that and figure out what that might be. If you look at the unit circle, 1 pi radians is at the 180, and pi over 2, half a pi, is at the 90. So 2.3 should be in quadrant 2 because it's between 1.5 and 3.14. Right? This is 0, half pi, 1 full pi. 1 full pi is 3.14 approximately. And then half a pi would be half of 3.14 would be 1.5. So 2.3 should be in here. And if it's in quadrant 2, we have to subtract our angle from pi. So approximately 3.14 minus 2.3 gives me 0.84. What about negative 135? Negative 135 is down here. So it's in quadrant 3. So we really want this angle in here. So we can take 180, which is this angle here, subtract my 135, which get 45 in here to the x-axis. What about 362? 362 should be 2 degrees because it's already more than one circle all the way around the circle, and it would go past it by 2 degrees, so we have to come back to the x-axis by 2 degrees. About 358 degrees. 358 is almost one circle, so in order to get back to the x-axis we need 2 more degrees. So it's 360 minus 358. What is the reference angle for pi over 8? Well, pi over 8 is less than half a pi, so the reference angle is just pi over 8. Here's your question number 2. Find the reference angle for 7 pi over 8. Okay, we're going to evaluate the trig function. Before, I had you evaluate cosine of pi over 3, and we know that we can get that off the unit circle. But with something like this, first thing I want to decide is whether it's positive or negative. So I know that 3 pi over 3 is 1 pi, and that would be at 180. So this is a little more than that, so I'm in quadrant 3. And in quadrant 3, cosine should be negative, and we'll make sure that we remember it's negative. My reference angle is pi over 3 because we've gone past the 180 by pi over 3. So cosine of pi over 3 is 1/2, and because cosine of 4 pi over 3 in the third quadrant is negative, then the answer is negative 1/2. Cosine of negative 210. Negative 210, if you go backwards on the circle, it's going to be in quadrant 2. In quadrant 2, cosine is negative. And my reference angle for that would be 30 degrees, because that's how we get back to the x-axis. So cosine of 30 degrees, my reference angle, cosine of my reference angle is rad 3/2. But because we're in quadrant 2, it's going to be negative rad 3/2. Cosecant. Cosecant is the reciprocal of sine. And what quadrant are we in here? This is spun around more than one time because one full circle is 8 pi over 4, or 2 pi. So this is really 3 pi over 4. Well, 3 pi over 4 should be in quadrant 2 because it's more than half, less than 1 whole. So sine is positive in quadrant 2, so cosecant is positive in quadrant 2. So the cosecant of pi over 4, or the sine of pi over 4, is rad 2 over 2. To get the secant, we take the reciprocal of rad 2 over 2. Clean this up a little bit, and we get that. Cancel the 2's, and it's rad 2. And like I said, sine is positive in quadrant 2, so it's just positive rad 2. Okay, evaluate the trig function, sine of 7 pi over 4. Evaluate the trig function. Let negative 3 comma 4 be a point on the terminal side of the unit circle. Find the sine, cosine, and tangent of theta. Well, if you have this angle here, if I draw my angle here, right, if I draw it back to the x-axis, my reference angle is in here. So we have this triangle. You see how this triangle is in here with the right angle down here? Okay, and theta is here, which is my reference angle now. And this is negative 3 is my x value. It's going to the left, and it's going to go up 4, right? This point up here is left 3 and up 4. So I go left 3, up 4 with my right angle here and my reference angle here. So we want cosine. Well, we know that this is a 3, 4, 5 triangle. Just remember that the radius, the hypotenuse, is always going to be positive. Okay? X could be negative, Y could be negative if it's pointing down, but the hypotenuse is always, always, always positive. So doing this, find the sine of theta. Sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Notice that's negative because cosine is negative in quadrant 2, sine is positive. Tangent is tangent negative or positive. Tangent's negative in quadrant 2 because only sine is positive in quadrant 2. So you go negative 3 over, or I'm sorry, 4 over negative 3, that's negative. Okay. Given that tangent of theta is equal to negative pi over 4 and cosine theta is greater than 0, positive, find sine and secant. Okay, first we should figure out what the sines are. Tangent is negative 5 over 4. So tangent is negative in these two quadrants. Cosine's positive in these two quadrants. So we're talking about quadrant 4. So we're going to find the sine of theta. Let's draw ourselves a triangle. We're in quadrant 4, like I showed you over here. So let's draw quadrant 4. And it is, and we'll always draw the angle out from the origin and back up to the x-axis, so that theta is always up to the x-axis. If you put the theta in here, it's going to be wrong. So we draw it back up to the x-axis, and we know that tangent is opposite over adjacent. So we'll put the 5 and the 4 on here. Which one gets the negative sign? One of these numbers gets that negative sign. It's going to be negative 5 because we're going down, and positive 4 because we're going to the right. So that's how we get our negative 5 over 4. So just finding the hypotenuse, we have to use the Pythagorean theorem. A squared plus b squared is equal to c squared. 16 plus 25 is 41. Take the square root. So the sine of theta will be opposite over hypotenuse. negative 5 over square root of 41, and we just clean that up a little bit. Secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So secant of theta is hypotenuse over adjacent. Okay, let's, are you going to do this one? Given that sine theta is equal to 4 over 5, positive 4 over 5, and tangent of theta is a negative, find the cosine of theta.